Hello students, welcome you again in chemistry class, and in this video we will study about the physical properties of haloalkane and haloarenes. In previous video we have already studied about the preparation methods of haloalkane and haloarene, and I have given you some worksheet in the description box of that video. So I think you have done it very well, and if you find any problem regarding the worksheet and the video lecture, you can mention it in comment box. We will definitely solve your problem. Okay, so now let's start physical properties. First physical property is physical state. If we talk about the physical state, actually we can see as the number of carbon increases, as the molecular mass increases, the physical state also changes. Mostly it happens that the compounds which have low molecular mass, they are found in gaseous state. With the increase of molecular mass, their physical state changes from gaseous to liquid, and compounds having higher molecular mass, they are mostly found in solid state. Here we have some compounds and we are discussing their physical state. So you can see methyl chloride, methyl bromide and ethyl chloride. These compounds are, and one more is chlorofluoromethane. These compounds are found in gaseous state, and you can easily conclude that why they are found in gaseous state, because they have low molecular mass. इनका molecular mass जो है वो बहुत कम है, that's why they are found in gaseous state. And if the number of carbon increases and the halogen groups which is attached with the alkyl group, their molecular atomic mass increases, so their physical state changes consequently. So you can here see the higher members. Higher members means haloalkanes having 3 carbon, 4 carbon, 5 carbons, they are found in liquid or solid state. Okay, but here we have some different aspect here. Alkyl bromide and alkyl iodide become colored in light as they shows photochemical reaction in light. When they are exposed in light, their color changes. Okay, so these are the physical properties of haloalkanes. And if we talk about the density, density actually is also directly proportional to the molecular weight or molecular mass of a substance. Here we can see the density of alkyl fluoride and alkyl chloride is less than water. So we can easily say that these compounds, alkyl fluoride and alkyl chloride, can float on water as their density is low. And as I said, density is directly proportional to weight of haloalkanes. So here you can see methyl fluoride, methyl chloride, methyl bromide and methyl iodide. Here the number of carbon is same, number of hydrogen same, but the halogen having more atomic mass increases. Here fluorine, chlorine, bromine and iodine. As the molecular mass increases, the density will definitely increase. Okay. In the next example, you can see the halogen remains same. The halogen remains same. Here we have X, which represent the halogen, and it is same in all the compounds. But what the variation is there? We can see the number of carbon are increasing. As the number of carbon increasing, so the molecular mass also increases, and that's why the density will also increase. Okay, in next example you can see here the number of carbon are same. Here the number of carbons are same, so we can say they are isomers of each other, and these isomers have different density. And here we can see as the number of branches increases, number of carbon remains same and halogen remains same, the density decreases. Here you can see this is 1 degree butyl halide, this is 2 degree, sorry, this is not 2 degree, actually this is isobutyl halide, and this is 3 degree butyl halide. So here you can see the number of branches are increasing. As the number of branches increases, so density decreases. Okay, so here the density is decreasing. And in next topic we can see boiling point. So boiling point जो है, it is higher boiling point than hydrocarbon having same number of carbons. So we can conclude here that when the number of carbon having same number of carbons are same in haloalkanes and alkyl halide, so the boiling point of the compounds having halide group will have the greater boiling point, okay, because of the polarity. As the more the polar compound and more will be the boiling point. Okay, the next is boiling point is directly proportional to the molecular mass of haloalkane. तो हेलोएल्केन का जब मॉलिक्यूलर मास इंक्रीज होगा तो उसका बॉइलिंग पॉइंट भी इंक्रीज होता चला जाएगा. तो यहाँ आप देख रहे हैं कि मिथाइल फ्लोराइड, मिथाइल क्लोराइड, मिथाइल ब्रोमाइड एंड मिथाइल आयोडाइड. Here the carbon is same but the halogen is changing, and halogen with higher atomic mass is increasing. So that's why the boiling point is also increasing. In the next you can see the number of carbon are same but the number of chlorine are increasing consequently, and as the number of chlorine increasing, so molecular weight is also increasing, and with the increase of molecular weight or molecular mass the boiling point also increases. So this is all about the boiling point. And if we talk about, where is the duster? Okay, if we talk about the next physical property, it is okay. We can also compare the boiling point of haloarenes. In case of haloarene, you can see we have benzene. This is fluorobenzene. This is chlorobenzene. This is bromobenzene, and this is iodobenzene. This is iodobenzene. So here we can see the benzene is same, but the halogen is changing, and halogen with greater atomic mass is changing here. So benzene has low molecular mass than fluorobenzene. Fluorobenzene has low molecular mass than chlorobenzene. Chlorobenzene has low molecular mass than bromobenzene, and bromobenzene has low molecular mass than iodobenzene. So in this case you can see when we move from left to right, molecular mass increasing, and with the increase of molecular mass the boiling point is also increasing. यहाँ boiling point भी क्या हो रहा है, increase हो रहा है. Okay, so come to the next. This is all about halobenzene. Okay, in case of dihalobenzene, there are so many variations. If we talk about the dihalobenzene, so let's take an example of this ortho dichlorobenzene. This is meta dichlorobenzene, and this is para dichlorobenzene. Okay. So here we have two factors which affect the boiling point of halobenzene, and these factors are, first we talk about boiling point, which has greater boiling point. Actually, out of these halogen compounds, we have greater boiling point in ortho dichlorobenzene. Ortho dichlorobenzene has greater boiling point. Okay, so in second number we can see the boiling point of para dichlorobenzene. इसको यहाँ बना देते हैं para dichlorobenzene, और इसको यहाँ बना देते हैं. It has less boiling point than the ortho dichlorobenzene, and meta dichlorobenzene has the least boiling point. So what may be the reason? Let's find out. रीजन को फाइंड करने की कोशिश करते हैं. तो यहां देखिए, इन फर्स्ट एग्जांपल यू कैन सी we have two chlorine. Okay, so if we talk about the dipole moment, so we can see that this chlorine has dipole moment in this direction and this chlorine has dipole moment in this direction. That means this orthodichlorobenzene has greater polarity, and more the polarity of a compound, more strong will be the intermolecular attraction force. So here the orthodichlorobenzene has greater intermolecular attraction force. That's why its boiling point is greater than paradichlorobenzene. But in case of paradichlorobenzene, we can see it has two chlorine, one in this direction and one in this direction. And if their chlorine are in opposite direction, in that case their dipole moment will be cancelled out, and it has zero dipole moment. That means it is non-polar. But why its boiling point is greater than metadichlorobenzene? Okay, the reason is, this is very important question. The reason is, in case of paradichlorobenzene, this compound is symmetrical, and symmetrical compound accommodate themselves in a crystal with a well-mannered way or well packing. So that's why it has greater boiling point. Okay. And in case of metadichlorobenzene, we can see we have two chlorines here, and one of the chlorine is in this direction and one of the chlorine is just not in just opposite direction, but it will decrease the dipole moment slightly, and because of this decreasement of dipole moment, its boiling point will decrease. So that's why it has least boiling point. It has least boiling point than the ortho and para dichlorobenzene. Okay, and let's talk about the melting point. अब हम बात करें melting point के बारे में. If we compare the melting point of a compound, so again we have three compounds: ortho, para, and meta. And if we talk about the melting point, actually para has greater melting point than other. Melting point, we are talking about melting point. This is para, this is para के बाद next we have ortho, and then we have meta. But in case of melting point, we have paradichlorobenzene has greatest melting point, highest melting point, because of its symmetrical arrangement. Actually, keep it in your mind that the compound which is more symmetrical will have greater melting point, because melting point is directly proportional to the well packed structure of compound in crystal lattice, and the compound which is more symmetrical will have the closely packed structure, and it will be difficult to change it into liquid by giving temperature. So that's why the paradichlorobenzene has greater melting point, and orthodichlorobenzene it has actually two factors. One is the symmetrical, it is not so much symmetrical, but it is more polar than other. So that's why it comes on second number. And if we talk about meta, it is neither symmetrical and nor it has very much greater polarity. So that's why we have this type of arrangement in case of melting point. Okay, so let's take another example, one very important. Sometimes it is asked that in case of isomeric alkyl halide, it is asked that arrange them in increasing order of their boiling point. So how can we find which has more boiling point and which has less boiling point? Let's find out. Suppose we have CH3, CH2, CH2 and CH2 and Cl. And second we have CH3, Cl, CH2, CH3, and third we have CH3, CH3, CH2 and Cl, and next we have CH3, CH3 and CH3 and Cl. Okay, when we comes down, we can observe that as we comes down, the number of branches of butyl halide or butyl chloride increases. So as the number of branches increases, the surface area decreases. ये चीज ध्यान रखें. Number of branches अगर increase हो रही हैं, then in that case the surface area of compound will decrease. And as the surface area decreases, molecular attraction force will also decreases, because intermolecular attraction force is directly proportional to surface area. Compound with large surface area have greater intermolecular attraction force. Okay, so if there is less intermolecular attraction force or the intermolecular attraction force is decreasing, consequently the boiling point will also decrease. Boiling point भी decrease होगा, because boiling point is directly proportional to intermolecular attraction force. Greater the intermolecular attraction force, more will be the boiling point. So here the intermolecular attraction force is decreasing, the boiling point will also decrease. Okay, so this is all about the melting point and boiling point. Except some cases, the order of melting point and boiling point remains same in case of alkyl halide and in case of aryl halides. Okay, and next we talk about the topic is solubility. Solubility is also physical property. Actually, solubility of compound in water, it depends on two factors. One of the factor is hydration energy and another factor is lattice energy. In case of alkyl halide, alkyl halides are less soluble in water. Alkyl halide are less soluble in water. Why does it happen? Because when you dissolve alkyl halide in water, the hydration energy which is required for the solubility of a compound is not in so much quantity that which can break the lattice energy or lattice of a compound. So that's why alkyl halides are less soluble in water. If we talk about aryl halide, in case of aryl halides are insoluble in water. So most probably aryl halides type of questions can be asked. Let's see, suppose we have this aryl halide. Okay, so in aryl halide we have two parts. One of the part is called hydrophobic part. Actually, why this is hydrophobic part? This is a large group, and this large group is hydrophobic, and this is hydrophilic part. So actually hydrophilic part of aryl halide is much smaller than hydrophobic part. So there will be greater effect of hydrophobic part in solubility. Okay, when the hydrophobic part is greater, the solubility is much less. Okay, so that's why aryl halides are not soluble in water. But in case of alkyl halide, as I said, they are soluble but they are very less soluble. But aryl halide is insoluble in water. So this is all about the solubility. So these are the things we discussed about the physical property of alkyl halide and aryl halides, and in next video we will see the chemical properties of alkyl halide and aryl halides. So today this is all for today. We will see you in next video. Bye.